All right, as Bill O'Reilly says, we'll do it live. All right. Okay, let's see here. All right, now let me ask you a question. What if I ask you to graph f of x equals the log base 2 of x? Now, before you do the graph, could you write that as an exponential equation? Mary, it looks like you can. How would you write that as an exponential equation?
I know if you like
Say it again?
draw like a circle and then like 2 equals, I don't know. I just know you can't.
Oh, you just know you don't know how to do it though.
No.
Who knows how to do it? Sam knows how to do it.
Maybe.
Okay?
So what I will do is have the exponent function and then graph the let's call it the opposite function, that is the
Okay, so if I've got log base 2 of x, what's my base?
is going to base 2,
2.
and then it's going to be to the x, to the x power.
Well, it's actually 2 to the y power equals x.
Yeah.
Okay? So you mixed up your variables. Now, just for fun, I'm going to switch this around. If this was y equals 2 to the x, how would you graph that, Eric?
I want to graph it.
Yeah.
2 to the 1 is.
So we've got, where's my asymptote?
The asymptote is at 1.
It's on the origin.
I'm at 0, yeah.
Okay? My important point is
0, 1.
0, 1. And then if x equals 1, y equals 2, right?
Yep.
Since I'm using a nice grid here. Can you see my grid? I probably should pick something darker. Well, I will pick something darker in a minute. Okay, and then if it's 2, it's 4. Okay, so it's going to look something like this. Okay, that's y equals 2 to the x. Now, what's the relationship between this equation, which I'm going to pick another color to graph in, and that equation? What's the relationship? I told you guys that yesterday.
They're inverses.
They're inverse functions, right? Okay. So normally with an inverse function, what happens? You're going to swap the x and the y variable, okay? So essentially, here's what I'm going to do. So if this is my original equation, I'm going to say x equals 2 to the y. And if I solve for y, how do I do that? What'd you say?
You just find a log.
So I would take the log of both sides, log base 2 of both sides, right? Okay? So this becomes log base 2 of x equals, what's log base 2 of 2?
Y.
It's y. Okay? And so that's what I got here. Okay, now let's talk a little bit about this for a minute. Going back to this red equation, what's your domain and your range? Vaucler.
Your domain. Is your x value, so it's positive and
Okay, so x would be an element of negative infinity to positive infinity because we always go from left to right, right? Okay, and can you tell me your range?
0, positive.
Okay, you're only half correct.
Oh, y is
Y is an element of 0, 0 to infinity, correct? Okay, so now we know, let me throw one more thing out here. The asymptote is where, Eric? Remind me again.
The asymptote is 0.
That's only half correct.
Y equals 0.
Y equals 0. Okay, So we know that when we're doing inverse functions, everything flips, right? Okay. So if everything flips, okay, what is my domain, my range, and my asymptote? Sarah, it must be your turn.
What? Want to say it again?
What's your domain, range, and your asymptote if everything flips from this red equation?
So your domain would be what the range is. So x is the element of 0 and infinity. Then the range would be the y is the element of negative infinity to positive infinity. And the asymptote would be x equals 0.
Very well done. Who's studying with Sarah tonight? Okay? All right, so your asymptote's going to flip, right? So instead of being along the x-axis, it's going to be on the y-axis. Okay? Now, one thing I forgot to ask, you've got your important point, right? Important point. And the important point is what, Din? Sorry, the important point for the red one is 0, 1, right? So the important point over here is going to be 1, 0. Okay, everything is going to flip. So rather than going through here, we're going to be going through here. Okay? Now, what else do we know as with regards to symmetry? Inverse functions are symmetric to what, Landon?
Symmetric. The origin.
Nope.
The y-axis.
Nope. Reagan knows.
I was thinking this, those same things, but would it be the x-axis?
No, that's what he said. No,
You said the y-axis.
he said the y-axis is not symmetric to either one. Inverse functions are symmetric to what, William? Save me.
Inverse function is it the origin, or is it symmetrical with origin, or some type of line?
Some type of line is the right
Is it
answer.
y?
Max,
Yes.
it is not symmetric to the asymptote.
Y equals X.
Y equals X. Is that what you were going to say, Tim? Okay. Yes, it's symmetric. Okay, so I'm going to draw a Y equals X line here. Okay, that's not an asymptote, that's just a symmetry. So this is going to be symmetric to that. And so in this case, well, one thing you could do, in fact, let me do this. Maybe this will make it easier. XY table. We know if X is 0, Y is 1, right? We know if X is 1, Y is 2. If X is 2, Y is 4. Correct? Okay? So that would mean if I did an XY table over here, what do I put for my X and Y table?
The opposite.
The opposite, meaning
X values would be what? So
1,
2, 4, 1, 0,
0,
2, 1, and 4,
2,
2.
1, and 4, 2, right? Okay? And so as we see this, 1, 0, I've already got it here, 2, 1, and let's see, 3, 4, 2. Okay? So it's going to look, so you can see if you folded, I folded my board over that Y equals X line, you can see that that is a mirror image across the Y equals X line. Does that make sense? Okay. So that leads to a couple of rules, 2 rules for log graphs. Rule number 1 is what? Sir?
Well, I just have a question. So, what would symmetry over the origin look like? Because that not symmetry over the origin?
It could be symmetry over the origin, but that's not the definition of an inverse function. Symmetry across the y equals x1. So it is possible, and yes, this would be symmetrical about the origin, but that's not the definition. Okay? All right. Okay, so now the two rules for log graphs are easy. Do you remember the two rules for the exponential graphs? You don't remember? We can just do the quiz today.
Yeah.
You didn't remember those two rules? What are the three things that I wanted on there?
The asymptote.
Okay, so that's one of the rules. Asymptote is where on the exponential function?
On the y equals 0.
Y equals 0. Rule number 2,
Important point.
the important point. See, I would have made that rule number 1, but it's okay. Okay, important point is where?
At 0, 1.
0, 1. Okay, so now that you know those, what do you think are the two rules for log graphs?
Asymptote x equals 0.
Asymptote at x
Don't you mean
equals
it's
0.
1, 0?
We're assuming it's not shifted. What'd you say?
Don't you mean it's 1, 0 for the important point?
Well, we hadn't gotten that far
And
yet.
then the important point is 1,
The
0.
important point
Oh.
is 1, 0.
I'm
Okay?
looking at old rules, okay.
See, she's doing the rules backwards. It messed up Eric too. See? Okay? So those are your two main rules, okay? And that's any base. I'll put in the book, they put an A for any base. Okay? So that works with any base. Your important point is always going to be 1, 0. Your asymptote is x equals 0. Now, by the way, I don't think I reviewed this yesterday. What's the log base 7 of 1? I'm having a hard time remembering the name. Oh, gosh, can't remember.
Me?
Yeah,
Oh, Mauricio.
Mauricio, how did I forget that? Log base 7 of 1 equals?
7,
Oh,
1.
you let me down. Caitlin remembers. I told you guys to remember this yesterday. You've already forgotten.
Base 7, so 7.
Isn't it 0?
I think Natalie knows.
What is it, Natalie?
It's 0.
0. Okay, Mauricio, here's your chance. Log base 3 of 1 equals?
0.
Oh, there we go. Log base square root of 4,728 of 1?
0.
0, okay? Now you remember that rule. Don't forget that rule again. Okay, that means that this point is always your important point because the log of 1 is always 0. Hence, that's why we have that. Okay? The reason why, if you were to rewrite this as an exponential equation, how would you rewrite this as an exponential equation, Daniel?
You do the base 7,
Base is 7
and then the first power for the 0.
to the 0 power equals 1, right? How would you do this, Inoki?
It'd be 3 to the 0 power equals 1.
And Landon?
It would be the square root of 4728 to the 0 power equal 1.
Okay, gave you the best one,
So
huh?
I was just laughing at it, yeah.
Okay, all right. So yeah, that's why that's the important point. Log of 1 is always going to be 0. Here, let's just review this again. Log base 8 of 8 equals, make me proud, Alyssa. But don't look at your calculator. You should know that
I was
one.
looking at my notes.
Oh, 1, okay. When the base and that number are the same, it's always going to be 1, okay? Okay, so are we good there? Should we start doing some shifting around? Okay, let's do some shifting around. I'm gonna erase this. All right, how about what is g of x equals 2 plus the log base 5 of x. Mary, it must be your turn. Where's my important point?
1, 0.
1, 0. Okay, that's where I'm going to start. Now we're going to start shifting it, right? Does it shift?
2.
2 in which direction?
Right.
You sure?
Is that 2?
I don't know, is it? You sure?
Yes.
You sure it's up 2?
Yes.
Okay, good. So we're going to shift it up 2 because of the 2, right? That shifts it up 2. Where's my asymptote?
2. 0.
You sure?
Yeah.
No.
That's not.
No, I'm cheesing it in.
Okay.
You're going to shift your asymptote up 2. Okay? And what does your general shape look like? Does it go from low to high or high to low?
High to low.
You sure?
Yeah.
No.
Low to high.
It goes from low to high. Okay? Goes something like that. Okay? So the 3 things that I'm looking for tomorrow are
The important point.
the important point, which is right there,
The asymptote.
the asymptote,
And
and the basic shape.
So wait, the asymptote didn't move,
Asymptote moved up 2,
but I can't.
but it didn't shift left to right.
Okay.
That's correct.
So how do you know if it's going to be a vertical asymptote?
It's always a vertical
It's
asymptote.
always a vertical with a log.
With a line.
Okay, so how do we shift it left to right, the asymptote?
Well, that's a good question. How would you shift this? Let's change this equation so that it shifts left or right. What could I do to this equation to make it shift left or right? X plus 2. So if I put in parentheses x plus 2, that would shift it left 2. Okay? That makes sense? All right, let's do another one.
And would that also shift the asymptote? As well?
Yeah, that would shift the asymptote. Yeah, shifts. It shifts. It both shifts the. What does it shift? It shifts the asymptote, and it also shifts the important point, right? Isn't that such a great name? I came up with that.
So the bottom number, it doesn't necessarily matter, like log 5x or whatever the number is. It doesn't.
Okay, that's a good question. What does this 5 do to me?
Just impact it
It's the steepness of your curve. So I guess that is a good question. In fact, did I draw that picture? Let's see how good I drew my graph. Oh, that graph is really hard to see on there. Sorry, people at home. But let's see. Did I draw this steep enough? No. What should I have done?
More steeper.
More steeper. Okay. How do we prove that it's more steeper? What does that mean?
Or one thing that I always do is when
Here, let's pretend. Let's pick another color here for a second. Let's go back. Here are the other 2 colors I have. Let's just do y equals the log base 2 of x. And we're going to compare that with y equals the log base 5 of x. Okay? Let's draw both of those. We're not going to worry about any shifting for a minute. Just we want to compare what the bases are. Okay? So, if you wanted to plot points, This one you want to be very picky with what points you pick.
What?
1. Oh, by the way, I should ask you guys a question. What is the log base 5 of 0? And I'll let you cheat and put it in your calculator, but you better give me the right answer. Impossible number is the wrong answer. It's kind of right, though. What should you put here? Because don't put error. That's what most of you will put. That's because that's what your calculator will say. Any ideas, slogan?
Is it imaginary?
No. Because it's not the square root of a negative number. You should say it's undefined. Why is it undefined? Can I ever get to 0?
It's not in the dictionary.
It's not, that's where my asymptote is, right? I've got an asymptote right there. Can't take the log of 0. It's undefined. Okay? All right, so now
What about
log base 2.
0 of 5?
What'd you say?
What about log 0 of 5? What is that?
Log base 0
Yeah.
of 5. Okay, let's say that that's your thing. So that would be 0 to the x power equals 5. Is that even possible? It's not possible, is it? Can't raise 0 to any power to get 5. No way. Okay, so that one's also undefined. Okay? Good question, though. All right, now here's where we're going to get tricky here. Log of 1 is 0. You better get that right. Okay? Now I'm going to pick the log of 2. Log base 2 is 1. Log of, I'm going to pick 4. 2. I could write that as 2 squared, right? And then I can bring the 2 out front. And log base 2 of 2 is 1, and times 2 is 2. Okay, I'm going to pick multiples of 2 here. So I wanted to go one more, 8. What would that be? That would be 3. Okay? What if I picked negative 1? Tanner's shaking his head. What does that mean?
The asymptote grad you from over negative 1.
Well, what's your domain, right? What's your domain for the log?
0.
X has to be greater than 0, right? Not equal to, it's got to be strictly greater than. Okay? So negative 1's not in my domain. Correct? A couple other ones that you want to think about, though. How about 1/2? What's the log of 1/2? If you don't know, put it in your calculator. Not negative 1.
Negative 1?
Uh-huh. Oh, is it negative 1? Oh, you're right, it is negative 1.
Yeah, I was looking at mine.
Sorry, I was
I want to say
The
it.
teacher of the calculator.
All right, what's the log of 1/4? Negative 2. Why is it negative 1 and negative 2? Do you know why? How could I write?
Reciprocal.
I could write this as the log base 2 of 2 to the minus 1 power, right?
So it's going to be the reciprocal.
So it's your exponent. This is your exponent. Okay? I could write that as log base 2 of 2 to the minus 2 power. That make sense? Okay? All right, so as I'm looking here, I've got 1, 0. I've got 2, 1. I've got 4, 2. I've got 1/2, -1 and -1/4. Okay, so this is the slope of log base 2 of x. Okay, get rid of that. Okay, now what are some points I should pick for this one, x and y? We'll pick 1, 0 again, right? And then 5, log base 5 is a 5. Log base 5 of 5? 1. What's the next number I should pick? 25, right? And that's going to be 2. What are some good fractions I should pick? 1/5, -1, and 1/25, -2, right? Okay, so as we compare these here, I'm still going through the same point. 1, 2, 3, 4, 5, 1, 25. Can I even go that far? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, it's off the board. But anyway, so here's what we're going here, okay? So we're still going to go through here. 1/5, so it's going to get closer here. So it's going to be hard to tell, but it's inside, okay? So I guess you could say this gets steeper faster, in a way. But that's the difference that your base does. That's 5 versus 2. Okay, does that make sense? Oh, long answer, huh? Okay, so I'm not too concerned about the steepness of the thing. Like I said, the 3 main things I want to know. I want to know that point, I want to know your asymptote, and I want to know the general thing. Really quickly, what would be we didn't even cover very much. Log of x, -x plus 3. I don't care the base, 3. What would that do? The plus 3 is going to shift it to the left. So everything's going to go to the left. 1, 2, 3. My new asymptote is here. My important point is going to shift to here. And now it's going to flip how? It's going to go from low to high. Okay? All right, we didn't get very far in that section, but that's okay. As far as homework, hopefully you can do all the graphing stuff. Oh, I didn't talk about base 10 logs, but those are super easy. Oh, you can actually do a lot. Up through 34. Yeah, up through 34. That'll be the first one.